Right, so for this video, we'll be discussing May-June 2024 Pure Mathematics 3, Paper 3-1. So let's have a look for question number 1. They want us to expand this particular, the product of these two brackets in ascending power of x up to and including the term in x squared, simplifying the coefficients. Right, so if you have a look for the second bracket here, you're having 1 minus 2x with power half. Okay, so when you want to expand anything with power half, you actually need to apply binomial expansion. Okay, so to apply binomial expansion, there's a formula that you can apply here. You can have a look for the formula booklet. In the first page, there's a part where you can see that they are talking about the binomial series. Alright, so just for information, in AS level, in the A-level pure maths, in AS we are using the first formula, and for A2 we are using this second formula here. Alright, where the AS one, the n can be only integer. Alright, so where n is a positive integer, but for A2, n can be any rational number. N is rational. Alright, it can be a fraction, it can be a negative value, and so on. So we are applying this formula in our expansion here. For the first bracket, 3 plus x, there's nothing because it is power 1. So it is not needed for us to expand it. So we just expand the second bracket by using the formula first. Then after that, we expand the whole expression. Right, so let's start. So I tried to copy it over here for the formula that we have. Okay, so this is the formula that we are going to apply. Alright. Okay, so to apply this particular formula from the formula booklet, what we need to make sure is we need to make sure the first term in the bracket that we want to expand must be a 1. Alright, so this is the small details that you need to know before you can apply the formula. So we are having this one must be a 1. Right, so let's have a look for our question. So our question, we are having 1 minus 2x power half, which means that we can directly apply the formula here. Okay, so 1 minus 2x power half. If I try to apply it in the formula that we have, you need to know that, okay, 1 is a 1. So the plus x here, the x here, I have to replace it by using negative 2x. Then the n is actually the half. Alright, so we just apply the formula according to what we have in the question. So 3 plus x is a basic power bracket with a power 1. I don't need to expand it anymore. So for the second bracket here, first term is a 1. So I put a 1. Second term what I have here is nx. So what is the n here? So my n in the question is half. X is the negative 2x. So I'm having half multiply with negative 2x. Then how about the third term? So the third term will be n minus 1. So n is a half. N minus 1 means half minus 1. You are getting negative half. Divided by 2 factorial. Okay, then multiply with x squared. So what is my x here? My x will be negative 2x. And then you square it. Okay, so I will stop at the term that involve the x power 2. Because in the question itself, they did mention that we just include our answer in terms of x squared, up to x squared. Right, so therefore, you can continue if you want, but basically, it is not needed. So we will just stop at the x squared here. Alright, so next term, just try to use the calculator and simplify all your terms in the second bracket. So I'm having 1. So minus x, then minus half x squared. Okay, and after that, we need to expand these two brackets because this is bracket number 1 multiplied with bracket number 2, right? So you have to expand them. So to expand them, I have to expand it term by term. Where we are looking this 3, I have to multiply with 1. So I'm having a 3. Then 3 multiply with negative x, I'm having negative 3x. Then simply happen here, 3 multiply with this, I'm having negative half x squared. For the x in the first bracket, so x I want to multiply with 1, I'm having the x. So x multiply with negative x, I'm having negative x squared. And I'm not going to multiply x with this term because of I will get x power 3. So which is not needed in our question as well, right? So I will just take the x multiply with the first two terms in the second bracket, and next step will be just simplify them. So if you try to simplify them carefully, so by right, your final answer will look something like this. Okay, so you can see that we have get our answer up to x squared. Right, so this is how we solve question number 1. Okay, so question number 2. We need to solve this equation that involves the ln. So give your answer correct to 2 decimal places. Right, so when you want to solve the equation that involves ln, right, most of the time we actually have to apply the commonly used property that we have for the ln. So as an example, you need to know that if I'm having ln A plus ln B, we can basically combine them, become ln AB. A multiplied with B. Alright, so this is something that we commonly use. Okay, so what else do we have? If I'm having ln A minus ln B, basically you can combine that and become a single ln with A over B. A divided by B. Okay, and another one is if let's say you're having ln A equals to X, how can you rephrase it become something without the ln? So ln is a log with base e, right? So if you want to make the ln disappear, you have to bring the base to the other side. So you're having a equals to e power x. Okay, and after that, another one which is commonly seen one is this one, where we're having ln a power n. You can actually pull the n in front, make it become n ln a. So these are something that we use it very common or very frequently when we have to solve some equation that involve the ln. Okay, so let's have a look for our question here. So I'm having ln, so x minus 5 equals to 7 minus ln x. So for a small technique that I use here usually is I will group all the terms with ln at one side. So I will move the ln x to the other side. And from here you can see that on the left hand side I'm having all the terms with the ln, where ln something plus ln something. So I'm having something like this, ln a plus ln b. So I need to combine them by using the property that I showed you just now. Okay, so ln a plus ln b will be equals to ln a multiplied with b, which means that I'm having ln. Now I take the a, which is x minus 5, multiply with the b, which is the x. That equals to 7. So to solve this question, if I want to get rid of the ln, so I will need to use the third property here, where I will need to bring the base e going over. So if I want to bring the base e going over to the right hand side, then I'm having e power 7 on the right hand side. Okay, then if I try to expand this whole expression here, okay, so you can actually observe that we get a quadratic equation. Alright, so you're having x squared with the x, then the e power 7 basically is the constant term. So this is a quadratic equation. So to solve for the quadratic equation here, you can't factorize it, right? Very obvious. So what we need to do is that we have to use the quadratic formula, which is negative b. b is negative 5 plus minus square root b squared minus 4ac. So b squared is negative 5 squared minus 4. A is a 1. C is negative e power 7. Then divided by 2a. Okay, and when you try to press calculator and get an answer, right, basically you are having two values here. So first one is negative 30.7. Another one is x equals to 35.71. Okay, then you have two answers here. Usually when you solving the equation that involve the ln, right, there's another thing that we need to aware, which is when you want to get any value, okay, for ln something, the bracket inside, the value inside must be a positive value. So we need to do a little bit of checking before we confirm the final answer. So negative 30.7, if you substitute into your x here, or if you substitute into the ln x here, you will see that when you press the calculator like ln negative 30.7, you'll get a math error, which means that I have to ignore this answer. Okay, then you try to substitute 35.71 into the bracket that involve the ln. Then if you successfully get the value, that means we should accept this as the answer and we should ignore the negative value. Alright. Yeah, so this is how we solve question number 2. Okay, so question number 3. We are having the variable x and y that satisfy the equation a power y equals to bx. And then we are having the graph. We are given the graph y over ln x, yeah? y against the ln x. It is a straight line passing through the point here. Okay, then they want us to find the value for a and b, giving each value correct to the nearest integer. Alright, so before we can solve the equation and find out the value for a and b, right, there's something that we need to aware. You need to know that in this graph, the 0.336 is actually the ln x, because our x-axis basically is the ln x, yeah. So ln x is equals to 0.336. And then for the y here, it is the coordinate of y, right? Because our y-axis is the y itself. So same thing happened for this one. This is basically the ln x equals to 1.31. And this is the value of the y. To get the value for a and b, right, the original equation that we have is actually this one. A power y equals to bx. Okay, and then how can I make this equation so that it involves the ln x in this equation? Because our graph provided is something with ln x and y ma. So now if I want to find the value for a and b from this equation, it will be better if we can get something that has a ln x in from here. Okay, so what we need to do is, like, first step, we can try to take ln both sides. Okay, so after I take ln both sides, then by applying the property of log or ln that I show you just now in question number 2, okay, so these are something that we will use it. Okay, right, so ln a power y, I can pull the y in front. So I'm having y ln a equals to, for the right hand side, it is ln b multiplied with x. We can separate it, become ln b plus ln x. So you can see that our original curve now has been converted into an equation that involves the ln x. Okay, so since I have the ln x, I have the y, I can substitute the value provided in the graph to form some equation and to solve them simultaneously. So first I want to substitute this value now. Okay, so at the point 0.336 and also 1.00. Okay, so substitute y as a 1, right? So 1. I'm having 1 ln a equals to ln b plus ln x. So what is the ln x here? So ln x is 0.336. Okay, so this is my first equation. Right, so what I want to emphasize here is, please take note that our ln x in the graph, our x-axis is ln x in the graph. Therefore, when you want to substitute the value for 0.336, this whole value is actually the ln x. Therefore, you can see that ln x here, I straight away substitute by using 0.336. Okay, the common mistake that students do is they will substitute ln 0.336, which is wrong. Okay, so the whole ln x is actually the 0.336. Alright, then after that, at the second point. The second point is 1.31, and also the y is 1.50, right? Okay, so substitute 1.50 into the y. So you're having 1.5 ln a equals to ln b plus ln x. So the ln x will be 1.31. Okay, then I can rephrase them. Ln a is equivalent to ln b plus 1.31 over 1.5. Or if you don't want, then you can just treat this as second equation and you can try to solve them simultaneously because you're having a and b in both equations. So you can solve them simultaneously to get the answer. Okay, so what I'm going to do now is I substitute equation number 1 into equation number 2. Okay, so 1.5 ln b plus 0.336 equals to this. Okay, then if you try to further simplify all the term here, by right, you have 0.5 ln b equals to 1.31 minus 0.504. Okay, then again, apply the property that I showed you just now. To get rid of the ln, you have to bring the e, base e, over. Okay, when you bring the base e over and press the calculator, by right you will be having 5.012826.863. Since they asked us to correct our value of a and b into nearest integer, right? So the value of b should be a 5. Okay, then after that, we have to substitute the value of b. Go back to either a or a 1 or 2 to get the value of a. Alright, so ln a is equals to 0.336 plus ln b. So please take note, yeah, when you want to substitute the value for ln b, please make sure that you put in the original value, the long value. Okay, so you can see that I substitute the value of b, which is the longer one. You shouldn't substitute the shortened answer, yeah? Okay, so put in the value of b, and again, to get rid of the ln on the left hand side, you have to bring the base e over, where all the power on the right become power lah. The number on the right become power, e power the number on the right hand side. So you'll get a long value for the a as well. Then again, try to correct your answer of a into the nearest integer, so it should be equals to 7. Okay, so this is how we solve question. Okay, so question number 4. We are given a complex number u, and they want us to express the u in this form, where r is positive value and also the theta is from negative pi to positive pi. Give the exact value of r and also the theta. Okay, so for the pattern that they want us to find, right, this is actually the modulus argument form for a complex number. So basically the r is the value of modulus u, and the theta here is actually the argument of the complex number u. Okay, right, so let's start to find out the r, which is equals to the modulus of u. So to get the modulus of u, it is square root a square plus b square. So I'm having negative 1 square plus negative 3 square. So the b here is exclude the I. Okay, so the I, b is actually the coefficient for the I. Alright, so the I shouldn't be included in the calculation for the modulus of a complex number. Right, then you try to expand everything here and simplify it. So by right, you should be having square root 4, which is equals to 2. Okay, then how about the theta? So theta, like what I told you just now, it is actually the argument of the complex number u. To get a complex number u, right, we actually have to observe, yeah, where is the complex number located. So this is basically in the fourth quadrant, -1 and -3. So -1, -3 basically is this one. So -1 is, oh sorry, it is not in the fourth quadrant. -1 and -3 is in the third quadrant. So the horizontal value here is a 1, because this is -1, right? So it's a 1. Then the height of the triangle is a 3. And the angle basically is this one. Okay, so I have to take pi. Okay, I have to take pi minus the basic angle inside the triangle. So this is what we need to do. Okay, and because of, we try to measure the angle from a positive x direction, right? So in a clockwise direction. So for any angle that measure in clockwise direction, it should be having a negative value. The negative here means that we measure it in the clockwise direction. Anti-clockwise direction will be positive, but the clockwise direction will be negative. So to get the answer, I have to put a negative in front of my calculation. Then I have to take pi, which is 180, minus the triangle, the basic angle in the triangle that we have, which is this one. So to get the answer in this triangle, right, it should be equals to tangent inverse the height over the base. So the height is square root 3 over the base, which is a 1. So it will be square root 3 divided by 1. Okay, then you use the calculator to help a little bit. By right, you will be having negative 2 pi over 3. Okay, for those who may be using the MS calculator, you might not get a nice exact form of the theta. So what you need to do is like maybe you can change it become degree form first, then only you convert it back into the radian form. Alright. So our answer must be in radian because of in the question itself they did mention that the theta is from negative pi to positive pi. So this is how I get the theta. Then I rewrite my answer again for the u in terms of the modulus argument form where it will be equals to 2. Then I'm having cos theta plus I sin theta. Okay. Yeah, so this is how we solve part A for question number 4. And let's have a look for part B. For part B now, they give us one complex number in the modulus argument form, which is v equals to 5, then cos pi over 6 plus I sin pi over 6. Then they want us to express the complex number v over u in the form of r e I theta, r e power I theta. Then again, r is greater than 0, theta is negative pi to positive pi. Okay, so just to recall back, so to recall back, what is the pattern that we have here for r e I power I theta? So again, the r is the modulus of the complex number, and then the theta here will be the argument for the complex number. Okay, so for this question, we are interested to find out the modulus for the complex number v over u, and then you can also want to find the theta, which is the argument for the complex number v over u. And we call this as exponential form, okay, of a complex number. Alright, then to find out the r, the modulus for the complex number v over u, and also the theta from v over u, there are two different ways that you can find out. The first one is you try to figure out what is the complex number of v over u first. So v, you try to press calculator to get the value for cos pi over 6. So 5. So maybe I will show you roughly how to get the method number 1, but basically I'm using the other method. Alright, so for method number 1 is you try to get the complex number v first. So for complex number v, it is 5. What's the value for cos pi over 6? So cos pi over 6 is actually sub 3 over 2. Okay, then I sin pi over 6, so sin pi over 6 basically is a half, so you're having half I. Okay, then you're having 5 sub 3 over 2 plus 5 over 2i. This is your complex number v. And just now in part number 1, we actually have the complex number u, right? So the complex number u is negative 1 minus sub 3i. So negative 1 minus sub 3i. So the first method is you try to find the complex number of v over u, where you can see from here, it is actually a bit complicated, although the step is quite basic. So I'm having u here, negative 1 minus sub 3i. And then to get a complex number without the I at the denominator, you have to rationalize it. Okay, so try to simplify this whole thing here. Okay, so try to simplify this whole thing here and everything. Then you get a complex number. So from the complex number that you get, only you try to find the modulus and also the argument for the complex number. Right, so basically this is the idea how we solve this question by using method number 1. But for me, I'm using some shortcut here. So I'm using method number 2. So for those who are interested, you can have a look for this method, Okay, then how are we going to solve it by using the method number 2? Alright, so for method number 2, I'm going to use a shortcut formula where I know that if I want to get the modulus for the complex number v over u, I can generally take the modulus of v divided by the modulus of u. How can I get the modulus of v? It is already provided in the question. The 5 here is actually the modulus of the v. Because this is the modulus argument form, right? So the r here is the modulus for the v itself, which is a 5. And what is the modulus for u? You have calculated it just now, which is a 2. So you'll be having a 2 here. So modulus of v over u is 5 over 2. So this is a shortcut formula that you should know about it if let's say you want to apply it. Alright, because it is not provided in the formula booklet. Then how about for the argument? So if I want to get the argument for v over u, there's a shortcut formula where it is argument of v minus the argument of u. Okay, so what's the argument of v again? So the argument of v is given here. This is the argument of v, which is pi over 6, minus the argument of u. So what's the argument of u that we calculated just now? So it is actually negative 2 pi over 3. So you need to take pi over 6 minus negative 2 pi over 3. Okay, so when you try to simplify this answer, right, you will have the value 5 pi over 6. So this is how we get argument for the complex number v over u. Comparatively to the previous method that I showed you, basically this is much more easier and shorter, right? Yeah, so after you get the modulus for this complex number v over u and also the argument for the v over u, then you just rewrite it again in the exponential form. So v over u can be written as the r, which is 5 over 2, e power I theta, so it will be 5 pi over 6i. Okay, so this is how we solve this question number 4. Okay, so let's discuss question number 5. Right, so we are given the equation, and then it is meant for the x from 0 until 2 pi. Okay, so find dy dx, and after that they want us to find the x coordinate of the stationary points of the curve. So when we are talking about the stationary point, basically we should try to link it with the dy dx. So you have to we know that at stationary point, the gradient of tangent should be equal to 0, right? So first you have to find out the dy dx first. After that, you let dy dx equals to 0, and you try to solve for the equation and get the x coordinate. And for this question, you can see that you're having a fraction here. So basically, when you want to apply, when you want to find out the dy dx, yeah, we can try to use the quotient rule. So quotient rule is something like this. When you are having a fraction or maybe an expression in rational function, so you can apply the quotient rule like this. Alright, so this is a general formula for the quotient rule here. Maybe I can try to copy it over. Okay, so let's have a look. How can we get the dy dx for this particular expression? Okay, so let's start. I'm having my y equals to cos square x, then e power sine x on top. So to get the dy dx, here you can see that my v is actually the cos square x. So in the denominator, you have to square the v. So that means I have to square the cos square. So I'm having cos power 4x. On top, I'm having v here. So I just copy the denominator up, which is cos square x. And I will need to differentiate the thing on top, differentiate u. So you get du dx. So that means I have to differentiate e power sine x on top here. So when I differentiate e power sine x, I get the original thing, e power sine x, then multiply with differentiation of the power. So differentiation of the power, which is sine x here, differentiate sine x, you'll get cos x. So this is the first term that we have in the formula. Then minus, how about the second term? So for the second term here is, you copy the thing on top, you copy the numerator. So I copy e power sine x. Then I try to differentiate the bottom. So differentiate the denominator. I have to differentiate cos square x. So let's have a look. If you have cos square x, that means cos x squared. When you want to differentiate it, you need to pull the power in front, right? So become a 2. Copy the bracket, power minus 1. Then you differentiate the thing inside the bracket. So differentiate the thing inside the bracket, differentiate cos, you get negative sign. Right, so all this basic differentiation, please make sure that you go and have a look and revise it, right? Therefore, when I simplify cos square x, This is what I get. So I will have 2 multiply with cos x multiply with negative sine x. And after that, for the next step, I need to make dy dx equals to 0. Alright, then before I try to solve the whole equation, maybe what I need to do is like I can simplify the term on top first, the term on the numerator. What can I do here is I can actually factorize out the e power sine x. And I realized that for the first and the second term here, both also have cos x. So I will need to factorize out the cos x as well. So I left only cos square x. Okay, then plus 2 sine x. Then cos power 4x. Okay, so how I get this one, you have to do a little bit of factorization. So I factorize out the sine and cos. Therefore, the first term left only cos square. I take out the sine and also the cos. Therefore, the first term left only negative 2 multiplied with negative sine x. Therefore, I have positive 2 sine x. Okay, so continue from here. Since I make dy dx equals to 0, right? If I move the cos power 4x over, the whole thing is still equals to 0. Then I will be having all this on top lah. So basically I'm having 3 terms here. The first one is this one, multiply with the second one is this one, then the third one is this. So I have to actually solve 3 equations here. E power sine x equals to 0, cos x equals to 0, and also cos square x plus 2 sine x equals to 0. Okay, then yeah, before I solve it, right, maybe I have to simplify them first. Yeah, I realized that I can actually simplify something. I can simplify this one, cos x and also cos power 4, it will become cos power 3. Okay, therefore on top I have no more cos x. So I have only these 2 terms here, cos square x plus 2 sine x. Okay, then divided by cos power 3. Yeah, I think this is the correct one. Okay, so you have to simplify them first before you want to move up the cos power 3. Multiply with 0. Okay, then now you need to solve only 2 equations on top. So sine x, e power sine x equals to 0. Then cos square x plus 2 sine x equals to 0. Okay, so to solve this equation, right, if I want to solve for sine x, I have to take ln so that I can make the sine x in front. But if you take ln, this side also you have to take ln. So ln 0, they will give you a math error. So there's no solution for this particular equation here. Okay, then of course we have to continue to solve the second equation here. So when you're having an equation with trigo, cos and sine, right, it will be easier for us to simplify them if you can group everything become sine or everything become cos. So as an example here, I'm having cos square and sine. So I think it will be easier if I make it become 1 minus sine square. Then plus 2 sine x equals to 0. So for your information, from here until this step, I'm using the basic identity, yeah, sine square x plus cos square x equals to 1. And therefore, your cos square x is equals to 1 minus sine square x. Okay, so when I'm using this identity, right, and I try to simplify them, eventually I also get a quadratic form equation in terms of sine. So this is a quadratic equation. Then to solve for the sine, of course, you have to apply quadratic formula to get the sine. So I'm having negative b, your b is negative 2, plus minus square root b square plus 4ac, then divided by 2a. Okay, then you try to press calculator. you have two values for sine x. The first one is 1 plus sec 2. Another one is sine x equals to 1 minus sec 2. Okay, so definitely we'll ignore this answer, this equation, because this equation is already more than 1. 1 plus sec 2 already more than 1, right? So it is impossible for us to have the solution, the value of x, when the sine value is more than 1. Okay, so we have to continue and solve the second equation. Alright, so we try to get the basic angle for this equation here. So the basic angle by right should be equals to 0.427. Okay, so how to get a 0.427? Make this value become positive first. Okay, then you take the sine inverse. So sine inverse this value equals to 0.427. Okay, then after that, only you can try to calculate the angle in different quadrants further to see what is your final answer. Okay, so if you take 1 minus 2, it is a negative value, right? Okay, so please make sure that you change it become positive first, yeah? So your basic angle is this one. Okay, so maybe I want to emphasize this part. This one is a negative value. When you press for calculator, ignore the negative value. Just get a basic angle by using positive value first. So it gives you the answer in the first quadrant, which is 0.427. And after that, only I go through different quadrants to get the answer. For this question, I'm having sign with negative value. So to get the sign with negative value, I have to accept the answer from third quadrant and also the fourth quadrant. Sorry, I think I labeled it wrongly. For the third quadrant, tangent is positive, so sign is negative. For the fourth quadrant, also the same. Cos is positive, therefore the sign will be negative. How can I get the answer from the third quadrant? So basically, I have to take pi plus the basic angle. Then for the fourth quadrant, to get the answer from this quadrant, I have to take 2 pi minus the basic angle. Okay, so to get the value for the x, I have to take pi plus the basic angle 0.427. So when I try to simplify it, I will have 3.57 radian. Okay, then after that, same thing happens for the fourth quadrant. You take 2 pi minus the basic angle. So by right, you will get 5.86 radian, correct to 3 significant figure. Okay, so this is basically how we get the answer for the x. Yeah, alright, so this is how we solve question number. Alright, so question number 6. Okay, by sketching a suitable pair of the graph, right, they want us to show the equation has exactly one root denoted by alpha in the interval 0 until pi. Okay, so first of all, we have to sketch the diagram first. Since they said we have to sketch a suitable pair of graph, right? So for this equation, we will separate into two parts, where I want to sketch y equals to cosecant half x. And another graph that I want to sketch will be y equals to e power x minus 3. Okay, so let's have a look for cosecant x first, yeah? Cosecant half x. Cosecant half x is actually 1 over sine, right? So 1 over sine half x. When we are going to draw or maybe to sketch the reciprocal function 1 over fx, so what we do is like, we try to think originally what graph do we have. So sine graph is this one. Okay, so this is y equals to sine x. If sine x, that means from 0 until pi. But if I'm having sine half x, okay, so if I'm having sine half x, that means for the stretch in x direction, I'm having the scale factor 2. So scale factor 2 means that I have to multiply all my x coordinate by 2. So you can see that originally the three main points for the x coordinate will be 0, pi over 2, and pi. So if I want to multiply the 2 for all the x coordinate, right? So 0 multiplied with 2, it is still a 0. So pi over 2 multiply with 2, you get a pi. And original pi, you multiply with 2, you get 2 pi. Okay, and after that, I want to sketch 1 over sine 2x. So to sketch 1 over sine 2x, basically we need to know that for all the x-intercept, okay, for all the x-intercept here, you are having y equals to 0, right? Okay, so y equals to 0 at x-intercept. Therefore, when you substitute y equals to 0 into your 1 over sine half x, you'll get an infinity or mass error. So that means these two particular line basically belongs to asymptote for 1 over sine half x. And for this center point here, maximum point will become minimum. So I'm having minimum point at pi. And then if I take 1 divided by the maximum value 1, 1 divided by 1, I get a 1. That means all the minimum value is still a 1 here. So my graph by right should look something like this for cosecant half x. Okay, therefore, if I further look at the range or the domain that they want us to sketch, right? We are only concerned about 0 until pi. So that means eventually I only consider this part of the graph in my solution. Okay, excuse me. So this is how we sketch y equals to cosecant half x. So this is a technique, a small technique that you might need to know, okay, to sketch those reciprocal function. Alright, but of course there's another option where you can try to just memorize the graph yourself. Also can. So either you memorize it or either you know the small knowledge here and then you try to sketch it out by using the original graph. Okay? Alright, so I already settled this part for cosecant half x. So let's have a look for e power x minus 3. Okay, so for e power x minus 3, I start with original graph for ex first, e power x first. For e power x, the graph will look something like this, where it will pass through always 1 at the y-axis. Okay, so the y-intercept is always 1 for e power x. And after that, I have minus 3 outside the basic function. So when I have minus 3 outside, that means I'm going to shift down the graph for 3 units. If I sketch the graph for 3 units, eventually my graph will look something like this, where the original x asymptote, the x-axis will be the asymptote, so you move it down, become negative 3. So now the negative 3 will be the asymptote. So when you want to draw the graph up, basically your graph will look something like this. So original intercept for the y is 1, you minus 3. So 1 minus 3, you get negative 2. So it means that after moving the graph 3 units downwards, you are having negative 2 here, the y-intercept. Okay, and again, so I only want to consider the part of the graph from 0 until pi. So that means I will need to start my graph from here, then going up. Right, so this is how the graph look like for e power x minus 3. Then this one is the graph y equals to cosecant half x. Alright, so I try to combine everything nicely together in the same diagram. Okay, so maybe for me, I will draw a pi here. Sorry, I think it's very... Okay, I need to redraw it again. Okay, so I'm having a pi. So this is a pi. And then for my cosecant half x, it will look something like this. Okay, so I try to label it y equals to cosecant half x. And then for the other graph is this one, e power x minus 3. So I should start it with negative 2. Then I try to draw the curve going up. Okay, and we need to show that there's only one root denoted by alpha. So the root basically appear at the intersection point of these two graphs. So for these two graphs here, you can see that there's only one intersection point available, and I will label this as alpha. So one intersection point also tells us that we are having one root, okay, between the domain of 0 until pi. Alright, so after you sketch the diagram, make sure that you label them clearly. So for me, I think I need to label this one, right? Okay, so for this curve basically is y equals to e power x minus 3. Okay, then I need to make a simple conclusion of this. Alright, so you can see that one intersection point can be seen. Hence, there's only one root between 0 and pi. Okay, yeah, so this is how we sketch a pair of graph and to show that there's only one root in the range provided, which is from 0 until pi. Alright, so let's proceed to next question, next part. For part number B, they want us to verify by calculation alpha that alpha lies between 1 and 2. Right, so to verify the alpha, right, where is alpha located? I have to refer back to the original equation provided here. I'm going to use the sign change rule, yeah? I'm going to use the sign change rule for the verification. Alright, so this is my original equation. What I need to do is I have to move all the terms to one side for this equation. So as an example, if I try to move cosecant to the other side, I will be having the function fx equals to e power x minus 3, then minus cosecant half x. Okay, then I try to substitute the value into the function 1 and 2, and I try to figure out and see whether is there any sign change can be observed or not after I substitute in the value between 1 and 2. If there's a sign change can be seen, that means the root lies between the value 1 and 2, right? Okay, so if you want, you can use calculator to help you. And of course, when you want to press calculator, try to have a look for your function first. And we realize that for the function here, there's trigo involved. Okay, trigo function or trigo value or trigo inverse involved. So when you're having anything related to trigo function, we have to make sure that our calculator has been changed into radian mode. So first I need to make this D become R first. So shift mode, then we go for radian. So that's the most important thing, yeah, because if you didn't change it become radian, then your answer here might lead you to a wrong answer. Okay, right, then after that I try to key in the function, so e power x, so I'm having e power x, okay, then minus 3, then minus cosecant half x means that it is 1 over sine x, so 1 over sine, and I want to put half x means 0.5x, then close bracket. Okay, all right, then now I want to input the value 1, so I press calculate, then put the value 1, then press equal sign. So they give you this particular value, which is negative 2.37. So I put in the value first, negative 2.37. All right, then after that, I want to substitute the value 2 into my function here. So I press calculate again. Then now I input the value 2, press the equal sign, and now I get 3.20. Okay, so from here, I think it's very obvious, yeah? For negative 2.37, you are having a value less than 0. And then for 3.20, you're having a value more than 0. So you can see that sign change appear between the two values of f1 and f2. Okay, so let us make a simple conclusion here. Sign change can be seen or can be observed. f1 and also f2. Hence, the root, which is the alpha, lies between 1 and 2. Okay, so this is how we solve part B. Then let's continue to the next part, part C. Okay, so for part C, show that if a sequence of values are in the interval 0 until pi, given by the iterative formula of this, then converge, and then it converges to alpha. Alright, so they give us an iterative formula, and we want to show that it actually can lead us to the answer alpha. And to make sure that it can lead us to the answer which is alpha, we have to prove that this iterative formula can be derived or can be arranged from the original equation. Alright, so let us start. So for original equation, I know that this is cosecant half x equals to e power x minus 3. And just now we know that the root for this equation is alpha, right? So to show that this iteration formula can help us to get the value of alpha, I have to rearrange the original equation into this iteration formula. So we do it slowly. So first, I want to move the negative 3 to the other side. Then I take ln both sides. I think the answer is quite obvious, right? So you're having x ln e, you apply the property of the log function, okay? And after that, log e is a 1. Ln e is a 1. Okay, since you know that ln e is 1, so maybe I put here. Therefore, if you rearrange your equation, you're having x equals to ln, then cosecant half x plus 3. Okay, yeah, so this is how we rearrange our original equation into the iterative formula to prove that this formula can help us to get the alpha, right? Okay, then let's proceed further. For part D, now they want us to use this iterative formula with an initial value of 1.4. To determine the alpha, correct to 2 decimal places. Each iteration is 4 decimal places. Okay, so they have give us an initial value of alpha, which is 1.4. So maybe for me, I will I will make this initial value as alpha 0. Okay, the initial value is 1.4. Okay, so to get the alpha 1, what we do is that we substitute the initial value into the iterative formula to get the first value for alpha. So substitute alpha into this equation on the right. So that means I want to have ln, then cosecant half x, so half multiplied with 1.4 lah. Okay, then plus 3. And I want to know what is the value that I get for alpha number 1. Okay, so again, we can key in the formula into the calculator and help us to get the value for each iteration. Right? Okay, so I key in the formula for right hand side here, the iterative formula, yeah? Okay, so for iterative formula, it is ln cosecant half x plus 3. So ln cosecant half x means 1 over sine. So 1 over sine 0.5x. Then the plus 3 is beside, right? Okay, then close bracket for the ln. And again, because for this particular equation here involve the trigo function, therefore your calculator must be in the radian mode. So take note on your unit here lah, for radian. Then now we need to start the iterative. So to get the values for each iteration, so first initial value is 1.4, right? So again, after you key in the formula, press the calculate, key in the value for the initial value, which is 1.4. So 1.4 and press equal sign. So for the equal sign here, this is your first iteration, 1.5156268081. According to the requirement in the question, right, they want us to have the iteration for 4 decimal places. So I will take the 4 decimal places answer, which is 1.5156. So 1.5156. Alright, then after that, to get the second iteration, you need to substitute 1.5156, go back into the iterative formula. So you can repeat this process by using calculator straight away. Okay, so I press calculate again, key in the value for first iteration 1.5156, then press equal sign. And from here, you can see that the second iteration that I get is 1.4940. So I write in 1.4940. So you have to repeat this process until we get the 2 decimal places answer repeated. Okay, so you compare 1.5156 and also 1.4940. 2 decimal places answer is not repeated yet because this one give you 1.52 and this one give you 1.49, right? Okay, so you have to continue until you get 2 decimal places answer repeated. So just continue further. So press calculate again, key in the value 1.4940, then press the equal sign. Then you get 1.497790776. So the 4 decimal place answer will be 1.4978. So 1.4978. Should I just stop here? If you double check the answer for 2 decimal places, it should be 1.50. Haven't repeated yet, so I just continue furthermore. So to get 4th iteration, press calculate again, key in the value 1.4978, then put the equal sign. So you get 1.4971. So 1.4971. Okay, double check the answer. You realize that, oh, this is 1.50. So the value has been repeated, right? Okay, so from here, very clearly that the root or the alpha should be equals to 1.50, correct to 2 decimal places. Okay, so of course for some students they want to try out more iteration to make sure that the answer is correct. Of course, you are allowed to continue a few more iteration to make sure that the value is the root is actually 1.50. So but from here I can see very clearly that it has repeated for twice, right? The value has repeated, therefore you can directly tell them that the root is 1.5. Okay, then let's continue further to part E. Now they want you to state the minimum number of calculated iteration needed with the initial value to determine alpha correct to 2 decimal places. So how many minimum number of iteration is needed to get the answer? So we refer back to our solution here. So you can see that we get our alpha equals to 1.5, the repeat value is at 4, alpha 4. So that means this is the first iteration, the second iteration, the third one, and this is the fourth one. So this is a minimum number for you to prove that, oh, the root is 1.5, right? You can of course verify by having more iteration, but the minimum number of iterations should be the 4. 4 iterations needed. So you can just directly tell them that the answer is 4. Alright, yeah, so this is how we solve this question number 6. Okay, so question number 7. On a single diagram, they want us to sketch the locus given by this equation, where z and w are complex numbers. So let's have a look for the first equation first. Okay, so to sketch a locus z, basically what you need to do is that you have to put it into the pattern z minus a complex number, then equals to 2. Right, so if I want to have z minus a complex number, right, so this value must be a 3, so that negative minus the 3, you get back a negative 3 here. Okay, then for the y, it will be negative 2i. So that negative multiplied by negative, you get the positive. Okay, then when you are having this pattern of the locus, right, the equation, basically it is a circle. So you should know that it is a circle with the center. So center will be 3 and negative 2, the complex number that we have, and then the radius is equals to 2. So equals to 2 means this one, this is the radius. Alright, then for the second locus, we are having w minus a complex number equals to w minus another complex number. So if I take it out, it will be 3 minus 2y as well. Then for this one will be negative 3 plus 4i. Okay, so basically this is a perpendicular bisector. For the point 3, negative 2, and negative 3 and 4. Okay, so we need to roughly know, okay, how is the locus look like. Right, so this is a circle, and basically this is the perpendicular bisector. Alright, so we try to put in everything in our single argand diagram. Okay, so my range need to be quite big. Okay, so let's have a look first, yeah. Make it slightly bigger. Okay, so for the x-axis, positive one, I need maybe 5 units. Okay, then for the y-axis, I need around 4. So that I can fit in my circle, yeah. Okay, then after that, for the positive y, I need until 4 also. Then for the x negative, I need until -3. So -1, -2, then this one will be -3. Real axis and also imaginary axis. Okay, so first locus is z. I want to sketch a z now. So z is a circle with center 3, -2, and also the radius is a 2. So center should be somewhere here, 3 and -2. And then if the radius is a 2, right, it will pass through this point, pass through the x equals to 3 at the x-axis, then 5, and then -4. So if I try to draw the circle, the locus for z, it should look something like this. It should be a circle with the center 3, -2, radius 2. Okay, then you just try to sketch it up first. So this is basically the z. Alright, so I'm done for the first part. Then now for the second part here, I want to draw a perpendicular bisector for these 2 points. So first of all, I try to plot these 2 points first, which is 3, -2, and also -3 and 4. So -3, 4 is this one. Okay, then I want to draw the perpendicular bisector for this particular line or these 2 points. Okay, I will strongly suggest you when you want to sketch the argand diagram, please make sure that you try to measure all your x and y axis so that your graph looks neat and also the scale looks nice. If not, when you want to draw the perpendicular bisector, it might lead you, or maybe the scale that you use is not even, yeah, then maybe you will feel confused, okay, when you want to draw the graph properly. All right, so if you try to measure it nicely, then by right, this -3, 4, and also this point, the line between them will pass through the 1 and 1. Should be, okay? And then where's the midpoint for between these 2 points here? So the midpoint, if you want, you should aware that it is actually on the point 1, 0. Also, it's at the point 0, 1. Okay, because you can see moving 3 units horizontally, 3 units downwards. Same thing happened here. 3 units horizontally, then 3 units downwards. Because if you have a look, the vertical distance is actually from 4 until -2, which is 6 units. Then the horizontal is also 6 units. Okay, so the midpoint will be 3 and 3. So it should be somewhere here. And now I want to draw perpendicular bisector. So I know this is midpoint already. Perpendicular bisector means that you want to draw a line that's 90 degrees with this dotted line. So 90 degree means something like this. 90 degree. Okay, and then because it is a perpendicular bisector, original distance is 6 units for the x and 6 units for the y, right? So perpendicular bisector also the same. It should be same unit for x and y. So that means if I move 1 unit downwards from here, then I will have 1 unit horizontal. So that means the next point will be here. Okay, so this is a guideline for us to join my point so that I can draw a nice perpendicular line. So my perpendicular line will look something like this. Okay, so this is basically the W. Okay, all right. Of course, the most important thing is please make sure that you try to label this as 90 degree. All right, then don't forget to label your locus, which is W for this one, and also the Z is a circle. Okay, then let's have a look for part B. Now they want us to find the least value of Z minus W for points on this locus. What's the meaning for Z minus W modulus? Okay, so z minus w, modulus means distance. So z minus w means the distance between z and w. And for this question, they are looking for the least value, that means the shortest distance between the z and w. So if you have a look here, you are having w here, you're having the z. So usually shortest distance between these two locus means that the 90 degree, the perpendicular distance, the shortest distance usually can be perpendicular distance. So we try to think around the point on this circle, right? Which point is closest to the line W? So if I take perpendicular distance means that if by right, it should be this line. The blue, okay, by using blue color. So this is the shortest distance. If my Z is here, and if my W is here, so the blue color distance will be the shortest distance between the Z and W. So this one you need to have some common sense on it. All right. Okay, then you have to decide by yourself where is the shortest distance. So after you know that this is the shortest distance, then you have to think a way. How should I find out the shortest distance here? Some students might say that I want to find out the coordinate for the Z, but it is quite impossible for us to do so. So what can we do is that we can use the property of the circle and also some common sense about the distance of the point. So we can have a look here. I know that this particular point is actually 0, 1. And the midpoint here is 3, -2. If I take the distance between these 2 points, which is the green color one, then minus the radius 2 unit, then I will get the blue color distance here. Alright, so I hope that you understand what am I talking about here, yeah? Okay, so for part B, I will write my answer here. Okay, so the least value of z minus w modulus. Okay, so like what I told you just now, I will want to find the distance between w and z. W is having the coordinate 0, 1. Z is having the coordinate 3 and -2. So the distance formula should be square root x1 minus x2 squared. So 3 minus 0 squared plus y1 minus y2 squared. Okay, so I get the green color area, the green color length. After I get the green color length, I want to minus the radius from the circle so that I can get the blue color area. So minus the radius is -2. Okay, then you try to simplify this part here. So I'm having square root 9 plus 9 minus 2. So 9 plus 9 is 18 minus 2. So your answer should be either square root 18 minus 2, or you can further simplify, become 3 sub 2 minus 2. Okay, so just to double check and see whether they want us to have exact value. Yeah, so highlight the keyword exact form. So your answer cannot be in decimal number, it should be something like this. Alright, so this is basically how we try to get the least value between the Z and also the W. Yeah, so here is the end for question number 7. Alright, so we are now at question number 8. They want us to use the substitution of u equals to 1 minus sine x to find the exact value. So I think you should highlight the word exact value, yeah. Okay, you have to integrate this one by giving the answer in the form of a plus b sub 2, where a and b are rational numbers to be determined. Okay, so they give us a very clear direction for this integration, so you have to use substitution technique to solve it. Right, so I usually start with the substitution given first. So I'm having u equals to 1 minus sine x. Okay, so first step, I try to find out du over dx first, the differentiation. So differentiate 1, you get a 0. Differentiate negative sine x, you get negative cos x. But from here, you can see clearly that du can be written as negative cos x dx. Alright, okay, then after you settle this part, of course, we still need to find the limit, change the limit from x to u. So you need to know that in our question here, all these values are the x. So I have to change it become u also. Okay, so all these are x, so we have to change it become u. Right, so let's start. When x is equals to, sorry, x equals to 3 pi over 2. What's the value of u? So u equals to 1 minus sine 3 pi over 2. Okay, so maybe you can try to just press calculator and help a little bit. So you're having 1 minus negative 1. So 1 minus negative 1, you get a 2 here. So your limit of u will be a 2 lah. Okay, then when x is equals to pi, what happened to the value of u? So u equals to 1 minus sine pi. And you are getting the value 1. Okay, so once I settle everything, that I have changed all the value of x, the limit of x become u, and I also try to rephrase everything du into dx, okay, then you can start to substitute all the terms or all the details in the question. So I'm having 3 pi over 2 here. So sine 2x divided by square root 1 minus x. Okay, then dx here. Alright, so before I can exchange everything, right, I might need to expand the sine 2x first. Okay, so I might need to expand the sine 2x first. So what is the general formula or maybe the double angle formula for sine 2x? Sine 2x can be written as 2 sine x cos x. Okay, so what's the purpose that I need to expand it become 2 sine x cos x? It is because of, if you have a look for our substitution here, all the terms are single angle. That means I'm having sine x lah, I'm having cos x. Right, so sine 2x will not help us in substitution, so we will just expand it so that all the sine and cos can be replaced into some substitution step later. Alright, okay, so this is the first step. So first step, we try to expand the double angle formula first for sine 2x. So I'm having 2 sine x cos x divided by sorry, wait, I can't really draw nicely. Wait. Okay. Square root 1 minus sine x. Okay, so next step, I want to change all the values slowly. First of all, I want you to have a look for this part. Cos x dx can be replaced by negative du. Okay, so cos x dx can be, I bring the negative over lah. Okay, then I will have negative du. Alright, then after that, for sine x, I can replace it by using sine x is equals to 1 minus u. Green color one. Okay, then 1 minus sine x is very straightforward. It is actually the u. Then change all the limit here. Okay, so now you realize that every single term inside the expression here, we can change it from x become u already. So now I start replace everything. So limit will be become 1 and 2 lah for the u. 2 I just copy first. Sine x, the green color part I know is 1 minus u, so I write it as 1 minus u. The blue color cos x dx, I will get negative du, so I put it at the back. Okay, then divided by my fraction. So what's the fraction I get here? Square root 1 minus x, 1 minus sine x. So 1 minus sine x, I get a u, so I'm having a square root u at the bottom. Okay, so from this step to this step, you can see that we have changed all the x become u. Then let us continue further and see how can we simplify the equation and then we apply the integration. Personally, I prefer to take out all the constant term. So the 2, I want to take it out. For the negative together with the du, right, I will multiply the negative inside the bracket on top. So I'm having u minus 1 divided by square root u, then du. Okay, so from here, comparatively, you can see that my expression now become much more easier or much more simple. So to apply for integration, what I want to do now is I separate them, become 2 fractions before I can integrate. Okay, so I separate them. U divided by square root u, you'll get square root u, so it is u power half. Then for the second fraction here, if you bring the square root u go up, then you're having u power negative half. So this is comparatively a very simple expression for us to integrate, right? So just copy the constant first, and now I start the integration. So u power half, power plus 1 become 3 over 2 divided by the new power. Power plus 1 become power half divided by the new power as well. Then now I want to substitute in the limit 2 and 1. Okay, so again, for my practice, usually I prefer to simplify first before I substitute in the value. So I'm having 2 over 3, then square root of u power 3. Okay, then minus 2 square root of u. And I want to substitute in the value 2 and 1. Okay, so first, substitute the value of 2 first. If I substitute 2 inside, so I'm having 2 over 3. U power 3 means 2 power 3 is 8, so I'm having square root 8 here. Then minus 2 times of square root 2. Then minus, substitute 1 inside, I'm having 2 over 3 multiplied with 1 minus 2 multiplied with 1. Okay, then now I further simplify all the terms here. 2 times 2, I get a 4. So 4 over 3 with square root 8. 2 times 2, I also get a 4. So minus 4 square root 2. Then 2 times 2 is a 4, so 4 over 3. Then plus a 4. Okay, then in this question, my final answer should be in this form, a plus b sub 2. So to get a plus b sub 2, I need to change the sub 8 into sub 2. Right? So 8 means 4 times 2, right? So you'll be having 2 sub 2 for the square root 8. Okay, so minus 4 sub 2. And then for this particular part, you just simplify the value. So if you simplify the value correctly, by right, it should be 8 over 3. Okay, then further simplify this particular part, 8 over 3 sub 2 minus 4. 8 over 3 sub 2, 8 over 3 sub 2 minus 4 sub 2. It is like you're having 8 over 3 apple minus 4 apple. Okay, so from that, I think you should able to get 4 over 3 sub 2. So rephrase it again. So you're having a negative 4 over 3 sub 2, then plus 8 over 3. Then from here, further simplify it into the pattern that they want. And you can see that this is what you get. Compare again with the instruction in the question. You can see that, oh, basically, this is what we have lah. Because a and b must be a rational number, right? Okay, so you can see from here, rational number is a and b with sub 2. Alright, so this is how we get the answer. Okay, so we are now at question number 9. The equation of two straight line L1 and L2, and it is given in the form of vector equation, where A is a constant. Then now they tell us that line L1, the line 1 and line 2 are perpendicular. So this is the information that they give us. So first, they want us to show that A equals to 4. To prove that the lines are perpendicular, we should know that the direction of the line multiply or dot product with the direction of the other line should be equals to 0 if they are perpendicular to each other. Okay, so the direction for line number 1 is this one. The direction of the line number 2 is this part. Okay, so since they are perpendicular to each other, right? So that means if I take these two direction dot product, it should be equals to 0. So maybe from here you can use this information to find out the A. Okay, so dot product means that you multiply x with x. 3 times 2 is a 6. Y multiply with the y, so you are having 2. Then z multiply with z, you are having negative 2a. That equals to 0. So from here, very easily, you can get the value a equals to 4. Okay, then let's have a look for part B. Besides perpendicular to each other, they also tell us that these two lines intersect with each other. So find the position vector of the point of intersection. Right, so when we want to find out the intersection point, basically what we do is like we let equation number 1 equals to equation number 2. So the first vector equation, if I combine them, I'm having 1 plus 2 lambda, negative 2 minus 2 lambda, and also 3 plus 4 lambda. So this is line number 1, and I let it equals to line number 2. So for line number 2, I'm having negative 1 plus 3 mu. Okay, so negative 1 minus 2 mu, then negative 1 minus 2 mu as well. Okay, so just for information, yeah, because in the first part, right, we have know the value of A, which is equals to 4. Therefore, you can see that here I directly put in the value for A equals to 4. So you're having 3 plus 4 lambda here. Okay, then what to continue next is, to find the point of intersection, I need to find the value for lambda and also the mu. There are 3 equations here, 3 pairs of equation here. Equation number 1 is the x coordinate, the x equation. So this is equation number 1. So 1 plus 2 lambda equals to negative 1 plus 3 mu. So you're having 2 plus 2 lambda equals to 3 mu. So I'll treat it as first equation. Right, then for the second equation, I'm using negative 2 minus lambda equals to negative 1 minus 2 mu. So if I get the lambda, it should be something like 2 mu minus 1. Okay, then of course, if let's say some of you want to use second and third equation to solve for the value, also can. So there are 3 pair of equation here, 3 set of equation here. You can use any 2 of them to get the value for lambda and also the mu, right? Okay, so now I want to get the value for lambda and mu. So I substitute equation number 2 into equation number 1 so that I can solve them simultaneously. Okay, so 2 plus 2 lambda from here, right, you get the value of mu, which is equals to 0. Okay, then after that, what's the value for lambda? So for lambda, the value is negative 1. Okay, so actually, if you already find the value for mu, right, you can directly get the intersection point already, right? Alright, because you can substitute the value of mu into the equation for line number 2, then directly you get the point of intersection. So it is not necessary if you want to find the lambda equals to negative 1. But if you want to find, also can, no problem at all, right? Okay, so once I get mu equals to 0 or lambda equals to negative 1, then you should substitute the value of mu and lambda into the respective vector equation so that you can get the point of intersection. Alright, so I will directly substitute it here. Okay, so the position vector for intersection point is for me, I substitute 0 into this vector equation. So you can see that it's negative 1, negative 1, negative 1. So I'm having negative I, okay, minus j minus k. Right, so this is the position vector of the intersection point. Okay, right, so let's continue to part C. For part C, they are telling us that A has a position vector of this. They want us to show that point A lies on the line 1. Alright, so if let's say we want to prove, we'll let OA, position vector of A, equals to line number 1 to see whether is the point line on the line or not. So I should compare all the components in OA and also the line number 1. So OA is negative 5, 1, and negative 9. Then equals to line number 1. So for line number 1, what will it be? It will be 1 plus 2 lambda, and then negative 2 minus lambda, then 3 plus 4 lambda. To prove that the point A lies on the line L1, what we need to do is we have to find out all the lambda in these 3 different equations here. If the lambda is having all the same value, that means the point A lies on the line. If let's say the lambda is having different values, from the three equations here, then A is not lying on the lambda. Okay, so for me, I will label this as equation number 1, equation number 2, then equation number 3. Okay, so from 1, I'm having negative 5 equals to 1 plus 2 lambda. So if you try to solve it, right, so you'll be having lambda equals to negative 6 divided by 2, so you're having negative 3. Okay, then from second part, second equation, 1 is equals to negative 2 minus lambda. If I try to solve for the lambda, I also get the lambda equals to negative 3. Okay, then from part number 3, equation number 3, I'm having negative 9 equals to 3 plus 4 lambda. So if I try to solve it also, I can get the lambda equals to negative 3 as well. Alright, so since you know that all the lambda is having the same value when you compare the position vector of A with the line of L, line number 1, therefore A lies on line 1. If the value of lambda is different, that means A does not lie on the line. Okay. Alright, so this is what we have for part C. And let's have a look for part D. Alright, so for part D, now they say point B is the image of A after a reflection in the line L2. So find the position vector of B. Okay, so before we can find out the position vector of B, we need to visualize a little bit about the whole the line. Okay, what happened to the line and also where the A located and so on. Alright, so just now in part A, okay, so let's have a look for this question one more time here. In part A, I know that the lines are perpendicular to each other. So that's the first information. Second information is the line also intersect. So when the line is intersect, the value of lambda is negative 1 and also 0. Mu is 0. Then for the third part, I know that A lies on line number 1. And now, they want you to find out the position vector of B. If I try to combine all the information I get in the previous part, right? Okay, so from part A, I know that line L, L2, perpendicular with L1. So, perpendicular. So that's the first information that I get. Second part, I know that for this particular point, it is the intersection point. So this intersection point coordinate is negative 1, and negative 1. What's the value for negative 1, negative 1, negative 1? You get the negative 1, negative 1, negative 1 when your lambda is equals to 0 and also lambda equals to negative 1. So that's the second part of part B. We get the information from part B here. This is the coordinate for the intersection point. Alright, and then to get the intersection point, the value of mu is 0, the lambda is negative 1. Alright, then from the third part, they tells you that point A lies on line L. So I maybe label, this is line L, right? So maybe I label point A here. Okay, so this is point A. What is the coordinate for point A? Yeah? So they tell you that this is the position vector, right? So if I put it in the coordinate form, it will be negative 5, 1, and negative 9. Negative 5, 1, and negative 9. Okay, then for part D, what they want us to find? They want us to find the position vector of B. If I want to find the position vector of B, right, where is the B? So B is actually the image of A after a reflection in the line L2. So now, try to imagine that this line L2 is a mirror. You reflect point A through this mirror. So where do you get your B? Your B will be somewhere here. Okay, then they want you to find the position vector of B. Okay, so how to find the position vector of B? Okay, there are two techniques that you can use here. The first one is coordinate geometry. Okay, so maybe I try to add in more information. Yeah, when A is at this value, right, I know that my lambda is equals to negative 3. Okay, so now this is the overall picture that we have, right? And then now we are looking for the position vector of B. If I use the coordinate geometry technique, you can see that actually the intersection point is the midpoint of A to intersection point and B to the intersection point is basically the midpoint of A and B, because after A reflect through the line L2, then you get the B, right? Okay, so you can see very clearly that the intersection point will be the midpoint. So I'm going to use midpoint formula to find out the B. So let's say B now is x, y, z. I don't know what is x, y, z. I want to find it out. Okay, so to find the midpoint, okay, so to find the midpoint, basically we are having x1 plus x2 divided by 2, right? Negative 5 plus x coordinate for the B divided by 2. Then 1 plus y divided by 2. And after that, negative 9 plus z divided by 2. And I try to compare with the midpoint. So from the diagram that we draw here, midpoint is negative 1, and also negative 1. Okay, then you compare x with x, y with y, and also z with z. So negative 5 plus x divided by 2 equals to negative 1. So when you try to solve it, your x should be equals to 3. Okay, then you compare the y coordinate. So compare it with negative 1. So when you try to solve it, you should have y equals to negative 3. Then for the z, you're having negative 9 plus z divided by 2. Compare it with negative 1 also. Then try to get the value of z. You're having a 7. So the B is having the coordinate 3, negative 3, and 7. So if we try to convert it into the position vector OB, it will be 3i minus 3j, then plus 7k. Okay, so basically this is the first method that you can consider to use, where we are using the coordinate geometry. Coordinate geometry, and use the concept of finding out the midpoint in coordinate geometry, right? So this is method number 1. So personally, I feel that this method is convenient and straightforward. But of course, you need to know how your overall situation, how your overall diagram looks like. Okay, where's the B, and then you need to know what's the A, and so on. So that's method number 1, where we use the coordinate geometry to solve it. Then you have another option. You can use method number 2, which is the vector equation technique. Okay, so for vector equation technique, basically we know that if let's say we are looking for a position vector of a certain point on the line, right? It actually determined by using the value of the unknown here, lambda. So you can see that when A is on line number L, the lambda is negative 3. Therefore, this is a coordinate for the A. When lambda equals to negative 1, negative 1, negative 1, negative 1 is basically the position vector, okay, that lies on the line L1. Then if I want to know the position vector for the B, right, I just need to make sure that I know what is the value of lambda that I should substitute so that I can get the coordinate for the B. So you can try to observe a bit about the changes of lambda in A intersection point, then you can guess the lambda value for B. So you can see that A is lambda negative 3. Then intersection point is lambda negative 1. So the difference is 2 units, right? So from negative 3 to negative 1, the difference is 2 units. So if I want to get the lambda for B, right, it should be the same distance as well, because B is the reflection of point A through the intersection, through the line L. So if I want to get the b, the value of lambda that I can guess is also 2 units away from midpoint. So a is lambda negative 3, intersection point is lambda negative 1. So we should guess that the b is having lambda equals to 1 because they are 2 units away from the intersection point. Right, so if you know that b is having the value of lambda equals to 1, then you can substitute it into the equation for line number 1 and get the position vector of b. So when lambda equals to 1, substitute into the line L equation. So your line L equation will be what? Will be 1 plus 2 lambda. Okay, then negative 2 minus lambda, right? And also 3 plus 4 lambda. Okay, so when you substitute it, you also get the answer 3, negative 3, and also 7. So this is basically how we get the position vector of B if we are using the vector method. Okay, so no matter you're using coordinate geometry or the vector method, basically they give you the same answer. So this is how we get the answer for question number. Okay, so we are now at the last question for this paper, question number 10. Given that 2x equals to tangent y, they want us to show that dy dx equals to 2 then over 1 plus 4x squared. Alright, so for this equation, we are having 2x equals to tangent inverse. Some students might want to change become y equals to tangent inverse 2x. Then you start to differentiate. You can do that. Or another option is you can make it as implicit differentiation. Alright, so no matter which method are you using, maybe I will show you both lah. Right, I will show you both so that you know what's the difference between them. But eventually, these two methods will give you the same answer. Right, so let's have a look for method number 1 first. Okay, so I know that if let's say I want to make y as the main object, right, in the equation, so y equals to, I bring the tangent over, so it will become tangent inverse 2x. Okay, so how can I get the dy dx? So for dy dx, differentiate tangent inverse 2x, you'll be having 1 over the 2x, you square it, then plus 1 square. After that, you need to multiply the differentiation of the bracket. So the differentiation of 2x, you'll get a 2. So you multiply with the 2. So this is a process of differentiation. Right, so you are having 2 divided by 2 square is a 4, then square plus 1. Okay, so this is method number 1. We use the idea of differentiation, okay, in tangent inverse. Okay, so maybe I just help you to recall a little bit, yeah, just in case you already forget. Use the formula of differentiation of tangent inverse ax, tangent inverse x, then you will get 1 over x squared plus 1. But of course, when you're having the 2x in the bracket, you have to multiply with the differentiation of 2x. Therefore, the 2 appear here. Okay, alright, so this is method number 1. Alright, so for method number 2, you can also try to consider implicit differentiation. What's the meaning of implicit differentiation? So basically it's like this. You just differentiate the equation as how it's shown. Okay, so like this is the original equation. So I lazy to rewrite it become tangent inverse 2x. So what I do is that I directly differentiate it. Differentiate 2x, I get a 2. So by right, you should write dx over dx. Okay, but dx over dx is a 1. So usually we don't write out 1. Okay, then how we differentiate tangent y? So differentiate tangent y, differentiate tangent, I got secant square y. Then because it is something related to y with respect to x, so I have to multiply with dy dx. Okay, so what do I have here is my dy dx is equals to secant square is 1 over cos square. So 1 over cos square, I move it over, become 2 cos square. So my dy dx is equals to 2 cos square y. So maybe until this steps, you'll find that the 2 technique here, different method also give you different answer. But again, for this cos square 2y, you can try to change the cos y become something related with x by using the original equation. So from here you see tangent y is 2x. If let's say I fix this as y and I'm having a right angle triangle, tangent y is 2x means that this is 2x, this is 1, so that the opposite length divided by the adjacent, you get 2x. Then what about the hypotenuse here? So the hypotenuse here will be 4x squared plus 1. Because you square this one, plus square 1 square, okay, plus 1 square, then square root. So this is what you get. Okay, then I substitute cos y. So cos y is 1 over square root 4x squared plus 1. And then you square it. And from here, eventually you can see that you also get the same answer as what you did in method number 1. Okay, when you square it, of course, there's no more square root, yeah. After you square it, no more square root, so you're having 4x squared plus 1. Right, so comparatively, you can see that maybe method number 2 is more complicated because you need to draw a triangle to help you and substitute the value for cos y. And then for method number 1, it will be more straightforward, where you're having y in terms of x, then you just differentiate by using the formula of tangent inverse. Okay, yeah, so this is just a small suggestion for you. If in case you want to use implicit differentiation, also it is a correct method, right? Okay, then let's have a look for part B. For part B, they said hence. Okay, so hence means that very likely when you are solving this particular part, this particular equation, you actually need to use some result from part A. Okay, right, so maybe you can directly start from here first. I want to find the exact value, highlight the keyword exact value for this integration. Okay, so for this integration, you can see that the question consists of two functions. One function is x, another function is tangent inverse. Okay, so what is the x? X considered as A, algebra. Tangent inverse considered as I, inverse trigo. Right, so when you have a product of two different functions and you want to integrate them, basically you have to use integration by part. So integration by part formula, integration by part. The formula is provided in the formula booklet. Alright, but I just want to show you here first. So when you want to integrate u dv, the answer is uv minus v du. So this part, okay, so this part is basically the question. So in the question, I need to identify what is u and what is integration dv. Okay, so how I decide which one is u and which one is integration of dv? We are using the Liates rule, right? L-I-A-T-E. Where L is logarithmic function, I is inverse trigo, A is algebra, T is trigo, then E is exponential. So from our question here, very obvious, and you can see that x belongs to algebra, tangent inverse to x belongs to I, the inverse trigo. Okay, so the higher group will be the u, the lower group will be the integration of dv. Okay, so now I know that A is lower, tangent inverse is higher, right? So you will let u equals to tangent inverse to x. And you let integration of dv equals to the remaining is x and dx, so integration of x dx. So this is the first step to start with integration by part. Okay, then for the u part, you find out the differentiation. Okay, so du dx, I have find out the differentiation just now, right? The result, which is differentiate tangent inverse 2x, you get this one, right? So directly you get 2 over 4x squared plus 1. Okay, then after that, for integration, integrate something with dv. Actually, here is a 1, we didn't write it out. So integrate 1 dv, you get a v. Integrate x, you are having x squared over 2. Okay, so after I get all this information already, I need to start using the integration by part formula. I copy the question first. So if I copy the question, what do I have here is half, that's 3 over 2 x tangent inverse 2x dx. This is a question. This is a question, so this is question. Then it is equals to uv. U times v. So where's your u? U is this one. V is this one, right? So the uv that I have here should be x squared over 2 multiply with tangent inverse 2x. Then you can directly substitute the limit for the next step. C minus here, put it as minus. See the intersection sign, so you put intersection sign. Your v is x squared over 2, so you put in x squared over 2 du. So you ask yourself, what's your du here? So du is equals to 2 over 4 x squared plus 1 dx. Okay, so you multiply it with 2 over 4x squared plus 1 dx. Okay, so this is how your equation look like for now. And then after that, don't forget to include also the limit here. Okay, so the limit is 3 over 2, then 1 over 2. Okay, so this is basically I substitute all the terms that I have here, uv, and integrate v du, okay, from what I have in the question. Okay, then next step, you try to substitute in the value first. Substitute 3 over 2 into x squared, so you're having 3 over 4 divided by 2. So 3 over 4 divided by 2, you're having 3 over 8. Okay, then tangent inverse, substitute 3 over 2 inside the equation, you're having tangent inverse 3. If I write out step by step, okay. Okay, then minus. I want to substitute 1 over 2 now into the equation here. 1 over 2 square, you get 1 over 4. Divided by 2, you get 1 over 8. Substitute 1 over 2 into the x here, you'll be having tangent inverse 1. This is after I substitute the limit into my first term. Okay, then for the second term here, I need to continue with the integration. I can simplify the 2 and the 2. So from here, I'm getting negative integration of 3 over 2, 1 over 2 with x squared over 4x squared plus 1. Yeah, all right, so now next step, try to simplify this one. Tangent inverse 3 will give you a value of pi over 3, which is 60 degrees. Minus 1 over 8. Tangent inverse 1 will give you a value of 45 degrees, which is pi over 4. Okay, so this part we can simplify later in the next step. Then now let's have a look for this one. How can we integrate this particular term here? Right, so from here I can see that on top I'm having x squared, at the bottom I'm also having x squared, so it is an improper fraction. Okay, so to integrate the improper fraction, what I want to do is I want to make it become proper fraction first. So how can I make it become proper fraction? Okay, so first step is, because I want to I want to separate this into two brackets, yeah. So for x squared, I want to make sure that my numerator also have 4x squared. So I multiply with 4. When I multiply a 4 in my equation, outside I have to divide it by 4 so that the equation is still the balanced equation. Okay, then next step, I want to separate this particular fraction, okay, the improper fraction into two fractions. So to separate them out, I must have 4x squared plus 1 on numerator. So to get 4x squared plus 1 on numerator, I need to have a plus 1 here. But to make it balanced, at the same time, I have to minus 1, so that the equation is still a balanced equation. Okay, so this part is a little bit tricky now, so maybe you need to consider very carefully how to do that. For some students, they might say that, can I like try to apply long division to get the remainder so that you can get the rational function, the proper fraction. So it should be okay also lah. But I think no need to purposely go and apply long division. So I think I can directly simplify it this way by adding some number and multiply the number into the pattern that I want. Okay, so next step is, after I do adjustment, right, I want to separate my fraction into this one. Separate the improper fraction into the proper fraction, where I will be having 4, then x squared plus 1. Divided by 4x squared plus 1. After that, minus 1 over 4x squared plus 1. So this is how we separate it, how I change a improper fraction become a proper fraction. And this first term here can be simplified as 1. Then this one is actually involve the integration, and finally we'll get something like tangent inverse. Okay, we learned how to integrate this kind of question before. Okay, but if you have a look for the original question on top, original term on top, right, we never learned how to integrate this improper fraction before. Okay, so therefore you have to do some adjustment so that I'm getting this one, this step. Okay, right. Then now, of course, before we continue, we try to simplify the term with pi first. So 3 and 3 can be simplified. So you're having pi over 8 minus pi over 32. Okay, so pi over 8 minus pi over 32. If you simplify them, you will have 3 pi over 32. Okay, then minus the 1 over 4 as a constant, you just copy it. And now let's have a look for some details here again. The first term here, it will be equals to 1. Then minus 1 over 4x squared plus 1, right? So this is what you have currently. To integrate 1, definitely no problem. How can I integrate 1 over 4x squared plus 1? Okay, so to integrate 1 over 4x squared plus 1, there are many different techniques that you can use here as well. Okay, so I will write it beside here. Alright, so to integrate, the first technique is you use the basic steps that we learned earlier to integrate 1 over 4x squared plus 1. Okay, so first step, what we need to do is we take out the constant 4, and your equation becomes 1 over x squared plus 1 over 4. Oh, sorry, plus, sorry, I take out the 4, right? Yeah, I take out the 4. So this one, you should be having 1 over 4. Okay, then after that, if you have a look for this one, 1 over x squared plus 1 over 2 squared. Okay, so this particular pattern, yeah, it is actually related to this. When you integrate 1 over x squared plus a squared. You'll get 1 over a tangent inverse x over a. Okay, so this formula is provided in the formula booklet. So if you're not really able to remember it, then you can have a look for integration part. Okay, then you can see integrate 1 over x squared plus a squared, you will have 1 over a tangent inverse x over a. Okay, all right. So this is what I apply now. Okay, I'm applying this now. Okay, my a is 1 over 2 lah. So 1 over 4 you just copy first. When you integrate, you will have 1 over a. So 1 over a. A is half. Then tangent inverse x over a. So copy the x. Then a is 1 over 2 also. Then please try to simplify it. So if you want to simplify it, you're having 2 over 4, which is half. Then tangent inverse x over half, you'll get 2x. So this is the first technique. When you integrate 1 over 4x squared plus 1, use the formula provided in the formula booklet, then you get this answer. So this is the first technique, yeah? Okay, then the second option is they are using the result from previous part. Okay, so they are using the result from previous part here, where you know that dy dx is equals to 2 over 4x squared plus 1. So we are using this result now, yeah? Okay, so let's continue. I show you the other result here. Okay, so just now in part A, I know that dy dx can be written as 2 over 4x squared plus 1. Okay, I bring the 2 over, keep the dy. Then I bring the dx over. You can see that I successfully separate the variable. Then you integrate them. Okay, and I want to know what is the integration for 1 over 4x squared plus 1, right? Okay, so this part I don't touch it. For left hand side here, 1 over 2 dy. Integrate half dy, you'll get half y. And what is the y here? I cannot substitute the value with the equation, the term with y into my calculation for the x now, right? So to replace the y, you go back to the question on top again. Here, you know that 2x is equals to tangent y. Therefore, your y is equals to tangent inverse 2x, like what we did just now. So y equals to tangent inverse 2x. So that means you go back to the question here, your integration is half tangent inverse 2x. So you can see that, again, this is another technique that you know, 1 over 4x squared plus 1, 1 over 4x squared plus 1, the integration that you get should be half tangent inverse 2x. Okay, so these are the two options that you can try to consider if you want to integrate this part. Okay, so let's come back to our main model here, the main solution. Okay, so 3 pi over 2, 3 pi over 32, just copy. Then minus 1 over 4, also just copy. Integrate 1, you get an x. Integrate this whole thing, you'll be having half tangent inverse 2x. So half tangent inverse 2x. Then don't forget to substitute the limit inside as well. Alright, then now let us substitute the value. Sub 3 over 2 substitute into the x, you get sub 3 over 2. Okay, minus the half, tangent inverse sub 3. Then now minus, substitute the half into the x, you are having half minus half tangent inverse 1. Okay, so for the remaining part, you just need to make sure that you simplify the answer very carefully without doing careless mistake. Then by right should be no problem for you to get the answer. Okay, so sub 3 over 2. Tangent inverse sub 3, you will be having pi over 3, which is 60 degrees. Right, so simplify all this, you're having pi over 6. 3 times 2 is a 6 now. Okay, then after that, for this part, negative half plus half. Tangent inverse 1, you get pi over 4. So half multiplied with pi over 4, you should have pi over 8. So I directly write as pi over 8, yeah. Okay, then now, slowly simplify every single term here. So 3 pi over 32 minus 1 over 3, sorry, 1 over 8 sub 3, then plus pi over 24, okay, plus 1 over 8, then minus pi over 32. Yeah, so after you expand everything, it should look something like this. You can group all the term with pi together. Okay, so if you simplify them, you have 5 over 48 pi, follow with 1 over 8 sub 3, follow with the fraction, which is 1 over 8. Okay, so you have to keep your answer in this form because for this question, they are asking for exact solution, exact value. Alright, so you have to keep your answer in this pattern. Alright, so the trickier part is actually, for this question, is actually this one. You have to really think and identify what is the correct technique that you should use for the integration. Alright, so here I show you two different techniques here so that you actually have the option at least to know how to get the integration for 1 over 4x squared plus 1. Right, yeah, so this is what we have for the whole paper in May-June 2024, paper 3-1. Right, thank you very much for watching the video. Okay, so the last question for this paper, question number 11. Okay, so we are given a field, right? In the field, there are 300 plants of a certain species. And then the first plant is infected are X infected plants. So the rate of change, highlight the keyword rate of change of X. So this particular phrase help us that you are having dx dt because the rate of change for the X. So the rate of change over the time, right, is proportional to the product of the number of plants infected. So equals to proportional. So proportional means there's a multiplication with a value k that we don't know yet. To the product means multiply. Number of plants infected, which is the x. Number of plants are not yet infected, which is the 300 minus x, because in overall, in total, right, we're having 300 plants. Therefore, the product of number of plants will be x. The not yet infected one will be 300 minus the x. So we recall and reread this whole sentence again, right? So you are seeing that, okay, the rate of change is dx dt, is proportional is k, product means multiplication, number of infected plant is x, then not yet infected is 300 minus x. So this is what we can get from this particular sentence. And now, the variable x and t are treated as continuous. Given that some extra information here, they want us to prove that it fulfills this equation. Okay, so since we already write out the expression for the differential equation just now, right? dx dt equals to k multiplied with x, then 300 minus x. And now, how can I prove that this equation is equals to this one? So I think the idea is very easy. You just need to try to find the value of k. Try to find the value of k and then rephrase this equation. Basically, I believe that you can get the answer that they want here. But how can we get the value of k? We need to have some values or some pieces of information to get the answer. So I will need to use the value here. Okay, so when x equals to 1, dx dt equals to 0.2. Okay, so given that x is equals to 1, then dx dt is equals to 0.2. So I'm using this particular information. I substitute into my equation on top. So I'm having 0.2 equals to k, I don't know yet. The value of x is a 1, then I'm having 300 minus 1. Okay, so when I try to simplify this equation here, I'll be getting k equals to 1 over 1495. Of course, you have to use calculator to help a little bit. Alright, and after that, if I rephrase my answer here, dx dt is equals to k. K is 1 over 1495 x, then multiply with 300 minus x. So I think the answer is very obvious. So you bring the 1495 to the other side, and this is how you get what they want us to prove. Okay, right, so this is how we get it. Okay, so let's have a look for the next part, part B. For part B, using the partial fraction, solve the differential equation and obtain an expression for t in terms of a single logarithm involving x. Okay, so we want to solve the equation here. First step, we have to rearrange the differential equation. Okay, I have to group all the x to one side, all the t to the other side. So one side is the x, one side is the t. Okay, right, so if I try to rearrange my differential equation, basically this is what I have. So I move all the x to one side. Okay, then I put all the dx here, x and dx here. That equals to, I bring all the number and all the other things, or maybe the t to the other side. So this is how I separate my variable in a differential equation. Then after that, only I put the integration sign. Okay, so for this part, they already give us a hint. This is a rational function, right? You have to use partial fraction before you can integrate them. So we need to try to find the partial fraction for this particular rational function here. Okay, so I'm having two factors here, and both of them are linear factor. Therefore, when I separate it, you will have a over x plus b over 300 minus x. Right? And after that, I multiply the whole equation with the original denominator. So I'm having 1 equals to a. Then multiply with 300 minus x. Then b multiply with the x. Okay, so now I have to look at this particular term here, bx. Look at the x. I want to get rid of the b. Therefore, I have to let x equals to 0. So I let x equals to 0. Okay, substitute x equals to 0 into the whole equation here. So I'm having 1, then a, 300 minus 0, you get 300. So from here, you successfully get the value of a, which is 1 over 300. Then how about the b? Okay, so to get the value for the b, I need to refer to this particular bracket here. I want to make this bracket become 0. So I will let x equals to 300. Okay, then 1 equals to 300b. So from here, you're getting b equals to 1 over 300. Okay, so I successfully get the partial fraction for before my integration. So I know that 1 over x, then 300 minus x equals to 1 over 300x plus 1 over 300 minus x. Okay, so now I'm going to substitute this the partial fraction into my integration. So let us continue further. Okay, so if I rewrite my integration equation again, for 1 over 300, right, they are constant, therefore I prefer to take them out for the integration. So I'm having 1 over x plus 1 over 300 minus x. Okay, then equals to, on the right hand side, I think nothing different. So it is still 1 over 1495. Alright, then after that, we can start our integration. Okay, so how to integrate 1 over x? So to integrate 1 over x, you will have ln x, right? Okay, then integrate 1 over 300 minus x. you will be having ln 300 minus x. Then you have to differentiate the thing inside the bracket. When you differentiate the thing inside the bracket, you have -1. So you have to divide it by -1. Okay, so integrate the constant 1 over 1495. You'll get a t here. Don't forget about the constant term plus c. Okay, then again, before I continue further, I will want to simplify my answer first, so that it looks nicer. Right, okay, and now my next part is I want to find the value of c because before I can simplify all my answer. Okay, all right, so I will want to find out the c first. Again, I will need to refer back to the original information given in the question, yeah. So on top of the question here, you can see they provide us with this value. When x equals to 1, t is equals to 0. Okay, so I'm going to apply it here so that I can find the constant value for the c. Okay, so when x equals to 1, and then t is equals to 0, right? Okay, so substitute it into my equation on top, my solution on top. Ln x is ln 1, then ln 300 minus x means you have ln 299. When t equals to 0 is nothing there, so your c is equals to this value. Right, then for your information, we simplify it further. Ln 1 is a 0. Okay, so again, when you look at your value of c, by right, it should be negative ln 299 over 300. Okay, all right, then now substitute your c, go back into the equation here. Right, so for this question, they want us to express t in terms of x. So to get our answer t in terms of x, we have to group everything not related to t to one side first. So this is a constant term. I will want to move it to this side. So if I want to move it to this side, right, eventually when I try to simplify them, I'm having 1 over 300, then ln x minus ln 300 minus x. Then the ln 299 bring over become plus, right? So you're having plus ln 299 equals to 1 over 1495t. Then continue further. You can still continue to simplify and group all the ln term become single ln. Okay, so I want to make it become a single logarithmic function. X is positive, right? Positive ln x, so the x should be on top. Minus ln 300 over x. Minus means that you have to divide it inside the single ln. Then you see the plus again. So the plus here means you have to multiply with 299. It will be on top. Okay, so it goes to 1 over 1495t. Okay, so next step, try to rephrase your answer again. So what's your t here? I will bring 1495 over. Okay, then divided by 300. Then ln 299x divided by 300 minus x. Further simplify it again. Okay, so this is the final answer for this question because they are asking you to find out the answer t in terms of a single logarithmic x. All right, so this is the answer that they want us to show, they want us to get. Okay, yeah, so here's the end of this question, also this paper. So thank you very much for watching this video.